Well, let me tell you a story. It's working at Home Builders Incorporated, and Home Builders Incorporated did construction. They built houses. They built modular homes, though. It was inside work. It was kind of nice. You didn't have to drive all over the county. You didn't have to get out in the rain. You didn't have to get out in the mud. Made life look fairly livable. Wasn't great pay, but they were hiring. So time went on, and I thought, I really got to do better than this because I get laid off every fall. So fall's coming, and I'm starting to look for someplace else to work, and I end up telling my mom, you always talk to your mom. I said, I really got to find a better place to be. I'd like to work at Borg Warner, but they're not hiring. She said, let me talk to some people. I don't know who she talked to, and I don't know how she did it, but I got a phone call. And I went out for the interview, and I got hired. Now, I think it was more somebody taking that my mom said I was good rather than anything else. But in any case, I started out at Borg Warner, and I ran a thing called a solder dip pot. Now, the reason I got the job was the guy that they had running the job was 6 foot tall. And he went on to become a welder. And they had an opening for somebody 6 feet tall. Guess what I was? I was 6'1" at the time. You get older, you get shorter. So life goes on and everything's fine, and working my butt off. Solder dip pot's hot, and I had to put the radiators on the dip pot and hit the button that made the float drive the solder up and touch the bottom of the radiator, and then the radiator would solder the header plate onto the radiator, and I would lift it up with a hoist, flip it over, and do the other end. But every time I did that, when I lifted it up, I had to take an air hose and blow off the solder. So that meant I wore a face shield because there was hot solder flying all over the place. I still got marks on my neck where I was wearing a t-shirt one day and one landed on my neck. Well, actually right here, just above my collarbone. So, wasn't the greatest job in the world. But I'd been a welder. I'd been working in the foundry. I'd done all kind of crappy stuff. It really didn't bother me that much that I was doing hard, hot, heavy work. It was more of a thing of, this doesn't pay much. So they had an opening. And I had done something prior that got me in the door. They needed a maintenance guy. And what I had done, the solder dip pot broke. The solder dip pot was this big 4x6 kettle of solder, about 2.5 feet deep, had a rounded bottom like a barrel. And the idea was to have enough solder in there to maintain the level of the solder so it wouldn't drop quickly. Because we took about, I'd say anywhere from 4 ounces to 6 ounces off every time we soldered a header. So eventually the solder pot would drop if you didn't have enough solder in there. That's beside the point. In any case, the solder dip pot had this steel frame that sat across the top of it and had the mechanism that pushed down a float that displaced the solder and made it come up into a little platform, and it would touch the header tubes and solder the header onto the tubes. One end, both ends were held down with a 1/2 inch bolt. 1/2 inch? 3/4 inch bolt. We'll say 3/4. Pretty good size. And one snapped off. Well, it seems that the solder dip pot was made out of stainless, and the bolt was made out of regular steel. And they said, well, we've got to weld that up. And they said, we don't have anybody, we'll have to send it out. And I said, I can weld it. And they said, you can? I said, sure. You got any rod? So they brought the welder over, and I got some 80-13. The 80 is the tensile strength, the 13 is the flux. We called 80-13 granny rod because it was real easy to weld. And I did something that kind of surprised them. I took a wire brush and I wire brushed all of the solder off the place where the bolt was going to go, and I ground off the old weld, and I cleaned off the bottom of the bolt, and I set it on there and held it in place and tacked it. And I straightened it up, tacked the other side, and tacked the third side. And so I had 3 spots around it so it would stay up straight. Then I went ahead and just welded it up. Now, they had welded it multiple times, and I could tell that because there was multiple welds on the solder pot. The weld had built up quite considerable bead because it kept making a pass and welding the thing on, or making a pass and welding the thing on. I was there 5 years. Prior to me being there, they broke off the solder dip pot bolt about once every 3 months. During the 5 years I was there, after I welded it, it never broke again. It's a matter of doing it right. They had people who said they were welders, like the guy who used to run the solder dip pot, but not necessarily welders. Didn't have any training. So, going forward, the opening that they had was for the maintenance department, because they'd had Jerry Copeland. He was the guy who did all the repairs and everything. Great guy, liked him. He needed a helper because he was just running himself ragged trying to keep up, and they were going to expand and put on a new building. They knew they needed more people. I said, well, I worked at the foundry in maintenance for 3 years, and I got hired. Now, there were other people that thought that they should have got the job, but really I was pretty well qualified. So that meant I took care of things around the shop and made sure things worked, and fixed equipment and wired stuff up and plumbed things and did all kinds of stuff. But I also did something that is kind of comes into the work I do here at the shop. One of the things that we did is we had lots of material in the building. We had steel plate, and we had brass strip, and we had copper strip, and several machines that ran. Well, we had punch presses and milling machines and forming machines and all kinds of things. One of the things that we had was called a tube mill. And the tube mill used copper sheet to form the fins in a radiator. Today, you buy a radiator, it's usually got aluminum fins. Back then, this was in the early 70s, everything was copper. Copper makes a better radiator than aluminum because it's a lot more durable. It's also repairable. Aluminum is not much you can do about it. If it springs a leak, you toss it. Not worth the trouble trying to make it seal up. You can put junk in it, and all that does is clog up your engine block and clog up the radiator. And you can take all kinds of fly-by-night crap off the shelf at O'Reilly's and try dumping it in there, but you're better off just getting another radiator. In any case, the fin mill, had a rotary head that was 2 rolls. One had punches in it that as it rolled around, a cam would drive the punch down. So as it rolled around, that punch would come out and go through the copper and into a hole in the bottom roller. So they had to be timed out perfectly, and everything had to work really, really carefully. So we had a guy that ran the fin machine and fin mill, and he was really good at it. He did a good job. So he'd been there quite a while, and people just pretty much trusted him to do the right stuff. Well, we built a new building, and we had a lot more radiators going through the plant now. So the fin mill was working pretty hard, and this guy was hurrying to keep up. To make it easier, one of the engineers decided we would build a rack to put his material on so it could be all closer, because he was having to drive an electric fork truck clear down the other end of the building, get the thing that he needed and come back. So they wanted to have the copper coils. It was thin. It's about 3 times the thickness of aluminum foil. And so we set up the rack, and brand new rack, bought it. It's supposed to be rated for 10,000 pounds. 10,000 pounds cumulative. That's not 10,000 pounds per shelf or 10,000 pounds per square foot. That's 10,000 pounds on the rack total, which is quite a bit of weight. That's 5 tons. Well, one of the coils could weigh 1,000 pounds. If you got a wide one, the widest one they ran was about 4.5 inches, and that one could go 1,500 pounds in a coil. So he was putting the stuff on the rack, and we built the rack, we put it together, we put on the 2x4 cross boards, the deck boards. That's what it was called for, 2x4s. Didn't have any stringers, didn't have any ties, cross ties on the thing. It just had the racks, big steel square tube, rectangular tube that crossed over and hooked into the ends over pegs, and very solid, good rack. Well, nobody bothered to tell the guy about point loading. Point loading is the difference between going and going like that. If you drive something that's got a small point on it into something, like a nail, you can drive it fairly easy. If you got a big surface, it takes a lot of pressure to shove it through. Well, they're called pallet racks. Yeah, there's a reason it's called a pallet rack. A pallet usually runs anywhere from, standards like 48 by 48, and they can go smaller than that. But 48 by 48 is the standard. If you have a pallet, the pallet is designed to take the weight and spread it out over a 4-foot square space on the floor, so the load is spread out over the floor. If you put it on a pallet rack, it's spread out over the pallet rack. It also limits how many pallets you can put on the rack. So these 10,000 pound pallet racks could handle, they were 10 foot long. That meant they could handle 2 pallets per rack, per shelf. And if you had a coil on a pallet, that meant that you had 2,000 pounds per shelf. 5 shelves, no problem. Put them all together, no problem. Whole thing could have 2 pallets on each shelf with 5 shelves, right at rating, never have a problem. It's all, there's one of those things, an assumption that always gets you into trouble. The assumption is everything is rated 50% over. And when you're engineering something, you look at it and you go, okay, it's designed to lift 1,000 pounds. After 6 months, it's going to be good for about 800 pounds because things are going to wear. Things are going to happen. Somebody's going to make a mistake. You want to give them room to make a mistake. But being the people that we are, humans and all, we tend to crowd that safety zone. So he was putting the pallets, and they told him put the heavy ones on the bottom. So he would put 4 or 5 coils on a pallet and set it on the floor underneath it. You could have as much weight as you wanted on the floor. The floor was going to be good for probably a ton per square foot. Good solid concrete floor built for machinery, reinforced concrete, about 12 inches thick. So good solid stuff. First shelf, second shelf, third shelf, fourth shelf, fifth shelf. Well, by now he's got all the heavy stuff on the bottom. And the heavy stuff is all palletized and ready to go. He's got a bunch of stub-end rolls. So he takes the stub-end rolls and he starts putting them on the top shelf. Well, if he lays them flat, they're hard to get up. He has a hook on the fork that he can go out and go through the hole and pick the thing up and set it on the floor. Or he can go into the pallets, pick the pallet up and move it out. Now, if he had said to himself, I will put these on a pallet and set them on the top shelf. But they were stub-in rods. They didn't get used much. It was for something like a radiator that had been obsolete for a while. We still had the parts because, you know, copper costs a ton, and you might get a use for it later. Well, he started standing them up on edge. Now remember, I said the widest was about 4 inches. The rest of them are a lot smaller. So as he racked them across there, he was adding up quite a bit of weight, even though each one probably weighed 300-400 pounds at most. Each one was anywhere from this wide to 4 inches wide. That means it just sat on a 2x4. 2 of them would just sit on a 2x4. Now you're taking a 2x4 that when I stand on a 2x4, I know that I weigh about 285 pounds. Yeah, I know I look like a lot more, but it's about 285. 285 won't break when I stand on a 2x4. It won't. I can put a lot of pressure on it. I can stomp on the thing. I can't break a 2x4 with my foot. A 1x4, I could snap it. So if I take something and I have 600 pounds and I put it on a 2x4, I expect I could probably snap it. So he's taking copper coils and putting them on this rack way up in the air, and they weigh 600 pounds. So he overloads the rack. Instead of having 3,000 pounds max on a shelf, he's now got every 2 inches on a 10-foot shelf, he's got 200 to 300 pounds. No cross ties. Remember how I was walking down the shelf up there? I was walking on the edges knowing what could happen. And the thing started to spread out and the boards were sinking down in. It's because the beams roll. When you put that much weight on them and you got a 2x4 onto the top of the beam, well, you've seen them. They've got a dip in them. And the 2x4, or in my case, a 1x4, goes down into that dip and locks in between the two rails. And that's what holds the 1x4 in there. It's stuck in between the two rails. But because the beam can take when it takes an extra load, it starts to deform. First thing it does, it tries to come down. Well, the 2x4 is holding it from rocking together. So it goes out like this. And the 2x4 doesn't break. It slips down through the rail. Okay, now we've lost 600 pounds of coil. Yep, you've lost that one. That was the first one. Then the cascade started. You lose one, you lose the one next to it too, because it then falls over and falls into the hole. Falls over and falls into the hole. Now we only lost about, I don't know, maybe 10 off the top shelf, 2 feet of coils off the top shelf. But that fell on the second shelf. Now the second shelf is overloaded, and not only that, it's dropping about 2.5, 3 feet. So it comes down and hits the second shelf, bam, and it breaks the board, falls down in, spreads the load. The second shelf now, even though it's sitting on a pallet, doesn't have rails anymore because they're spread out and the 2x4s are falling off the thing. The pallets fall down, so you go 600 pounds, 3,600 pounds, and on down. We ended up dropping the whole rack all the way down to the floor. It was a mess. Copper all over the place, coils bent and damaged. Fortunately, nobody was hurt. He was working off a fork truck. It fell in front of him. It did not land on him. He wasn't up there moving the things around by hand. If he'd have been on top of that rack, we'd have had somebody hurt. Or if we'd have had somebody walking by, we had somebody hurt because it fell into the aisle. Copper coils rolled all over around his fork truck. So that's why I put cross ties on these pallet racks. you could probably get by without them. When I first put a rack up over there, I knew I was only going to just stick some tools on it because I had put up the first rack and I wanted to see how it was going to go. So I didn't buy a lot of accessories. I didn't buy the cross pieces. I cut some 1x4s, made sure it was going to work. I immediately bought cross ties. That's why I looked up cross ties and put them on this one after I got the first one done. And then went ahead and did the top. So, harrowing story of my days at Borg Warner. There were others, but that was the one that kind of tied in with what I'm doing now. If you have any suggestions for a new video, questions about today's video, or any of the other videos on the channel, just drop a note in the comments. You know,